Everyone thinks silence is the absence of sound. They're catastrophically wrong. Sometimes silence isn't empty. It's just a cover, a canvas where unseen forces paint subtle soundscapes. And if you've ever walked beneath towering electrical lines, especially on a still, quiet evening, you might have heard it. A low, persistent hum, a song of invisible power. It's a sound that many dismiss as just electricity, a vague understanding that something powerful is at work. But what exactly makes those lines sing? It's not the current flowing through the copper itself. The answer lies in a fascinating interplay of physics, atmosphere, and a phenomenon called corona discharge. Imagine the air around a high-voltage power line. It's not empty space. It's filled with countless air molecules, nitrogen, oxygen, and a scattering of others. These molecules are normally stable, content to exist in their balanced state. But the power lines carry immense electrical potential, often hundreds of thousands of volts. This creates an incredibly strong electric field, a kind of invisible force field radiating outwards from the conductors. It's this field that starts the whole process. When the electric field becomes strong enough, it starts to get aggressive with those innocent air molecules. It strips electrons away from them, creating what are called ions, atoms, or molecules with an electrical charge. This is the beginning of the corona discharge. These newly freed electrons and ions accelerate rapidly in the electric field, colliding with other air molecules, stripping more electrons, and creating a cascade. It's a tiny, localized electrical storm happening right around the power line. And this cascade, this miniature storm, creates a series of effects we can both hear and sometimes even see. The most common sound is that distinctive hum. But why a hum and not just a crackle or a hiss? The electricity in our power lines isn't a steady, direct current. It's alternating current, or AC. This means the direction of the electrical flow reverses, typically 50 or 60 times per second, depending on where you are in the world. Each time the current reverses, the electric field around the line also reverses. This causes the corona discharge process to pulse. The ions and electrons are accelerated first in one direction, then in the opposite, 50 or 60 times a second. These rapid pulses, these tiny electrical explosions happening around the wire, create pressure waves in the air. And pressure waves, as we know, are what we perceive as sound. The frequency of these pulses directly translates to the pitch of the hum. In countries with 60 Hz AC, like the United States, the hum typically has a fundamental frequency of 120 Hz because the electric field peaks twice per cycle. In 50 Hz countries, it's 100 Hz. It's a precise, measurable physical phenomenon. But the hum isn't the only thing corona discharge creates. Sometimes, on very humid nights or during rain, you can actually see a faint, bluish-purple glow around the wires. This is the light emitted as energized electrons recombine with ions. This visible glow is a less common sight, but it's the same phenomenon that illuminates neon signs, just on a much smaller scale and with air as the gas. It's a beautiful, eerie testament to the power contained within those seemingly inert lines. Corona discharge also produces a small amount of ozone, a gas with a distinct, sharp smell, often described as electrical or fresh. If you've ever been near a large electric motor or a lightning strike, you might have caught a whiff. So, while the hum might seem like a simple byproduct of electricity, it's actually a complex symphony orchestrated by the interaction of high voltage, air molecules, and the alternating nature of our power supply. It's physics playing out right above our heads. Engineers work hard to minimize corona discharge. It represents a loss of energy, and over time, it can even degrade the insulation on the wires. That's why high-voltage lines are often thick and have multiple conductors in a bundle to reduce the electric field strength at the surface. Next time you hear that subtle hum, don't just dismiss it. Listen closely. You're hearing the invisible forces of electricity, the very fabric of the air, and the ingenious engineering that brings power to our homes, all singing in unison. It's a reminder that even in the most mundane aspects of our modern world, There are layers of incredible science waiting to be discovered just beneath the surface, or in this case, just above it. What other hidden phenomena are you curious about in your everyday life?